So the first thing we want to talk about are some words that we're going to want to make sure you associate with exponential growth. So when you're reading a word problem, like we talked about the RGCal word problem, we want to look for words that tell us that we are growing. So obviously words like increase, right? That's one of our key ones, increase. Obviously, if it says grow, I think that's self-explanatory. But there are some other ones that we want to think about, and a lot of them have to do with maybe the value of something, maybe the value of your home or the value of your car. So the value of a home typically does what we call appreciate, right? So if something appreciates, that means that it is increasing in growth. So to appreciate, it's not like saying, hey, I appreciate you, but if it's appreciating. So those are words to look for: increasing, growing, appreciating. Those are things to look out for. So the first thing what I want to look at is the value of some letters within a new formula. So I'm actually going to start at the bottom of this screen, which is off to the side for you. And I'm going to give you a new formula to think about. It really is, I want to remind you, it really is the y equals a times b raised to the x power. But it's got two new letters in it, r and t. So the first thing is, this is the formula we're going to use for growth. So y equals a times. So all that is the same so far. But then the new component comes in a set of parentheses. And it starts out by always being, and this is going to be the case every single word problem we do, it always starts out with a number one. That is the number one. And the reason what that number one is there for is the number one actually preserves or includes the original amount of whatever it might be. So if this was Ardrey-Kell, that number one is preserving the starting amount of students. It's including that number of students in the Ardrey-Kell. And then because that number of students is growing at Ardrey-Kell, we are going to add to it, right? Because it is growing, we are going to add to it. And we add to it based on a certain rate. So that's the letter R. And then once we've done that, that happens over a period of time. So we then raise that all to the letter T. Now you can use X if you want to, but we're just going to use the letter T in this case because that's time. So I've already kind of started to hit on these things. For example, T is your time. Now you want to be very careful that you think about how it's measured. So how is this being measured? So make sure you think about that, because it might be that it's years, it might be that it's months, it might be that it's days. So think about how that time is being measured. Then your R is your rate. Your R is your rate. So most of the time we think of this as a percentage. So if you remember back to our word problem with Ardrey-Kell, our rate of growth was 7%. We were increasing at a rate of 7%. But when we think about the percentage, you must, and this is absolutely vital, you must write your percentage as a decimal. You must write it as a decimal. If you write it as a percentage and you just write a 7 for Ardrey-Kell, it's not going to work. Now, moving back up to the A value, your A value is what we've always discussed. Your A value is your starting amount. It's your starting point. So when we think about AK, our starting amount was the fact that we had 1,100 plus students at Ardrey-Kell. So your A value is whatever you start out with. We talked about that the last time we met as well. And then the very last thing, obviously, Y is your final answer in a sense. Your Y is your ending amount, right? What you're actually looking for. That's the predicted amount. It's very often what we are predicting is going to happen. So in this case, we're saying, hey, how can we predict how many students we're going to have at Ardrey-Kell next year? So let's jump into an example. This first example gives us a starting time, which is important, 1971. It says in 1971, there were 294,105 females participating in high school sports. Since then, that number has increased, keyword there, that number has increased by an average of,
Good morning, everyone. It's about 10:45.
pardon
Just
the
want to give everyone
interruption
an update. I
there.
did finish meeting with all departments. A couple things for us.
All right, so folks, from here we've identified that we're starting in 1971. We are increasing, like we've said, and we've got our starting amount of athletes from the very beginning. So what's important is to be able to create the model that we're going to use. So you want to identify what your A value is, and your A value is our starting number of athletes. So we can already start out with Y equals 294,105 because that's our starting amount. Our starting amount is always going to be the A value. From there, we use our formula that we talked about, always beginning with 1 plus, so 1 plus R. So you cannot forget the 1 plus. If you do, your model doesn't work. 1 plus. And now we have to make sure that when we use our percentage, that we convert our percentage to a decimal. So you don't want to write down 8.5. If you write down 8.5, your model is going to be way out of whack. So if we convert our decimal, our 8.5 percentage to a decimal, that's going to be 0.085. And if you're not sure how we did that back in middle school, we just took our decimal point and we moved it 2 places to the left. That's dividing by 100. So our 0.085 is our rate of growth that we're talking about. So we've got our decimal there, and our model, remember, we're creating the equation right now. So our model is still being raised to some amount of time t. So here's our equation. But now we're going to use our equation to make a prediction. And because we want to know, well, how many athletes were there going to be predicted to be in 2008? So the first thing you want to think about is, well, you're not going to plug in 2008. You need to figure out how many years that's been. So you want to take your 2008 and subtract out the year that we started this whole thing, 1971. So when we subtract that out, we're left with, what's that going to be? Take away 1, we're at 2007. Take away, so that's 30. So that's 37 years, right? So now that we're at 37 years, we're going to take that number and plug it into our model. So if we do that, and this is all Desmos, we can type this into our calculators. So 294,105, 1 plus 0.085, all raised to the 37th power. And so here's where we get to get Desmos involved, because that can just type straight in. So on your Desmos app, or any calculator for that matter, all right, we're just going to type in that equation into the box, our first box right here. So 294,105, and then 1 plus 0.085 raised to, so be careful there, do shift 6 raised to the 37th power. And so we can see our answers automatically popping up. 6,017,314. So 6 million, you're going to have to look at both screens at the same time there. 17,000, 17, here we go, and 314 athletes. I think that was female athletes, actually. So there we go. There's our first example of creating the model and then using the model to make a prediction. So we're going to do a few more practice problems before we transition to exponential decay. Let's make it happen.